morning. Happy Monday. By this point in time in your logarithmic careers, you should have the change of forms memorized. Now, I'm not telling you how to live your life, but it's going to make your life a lot easier the quicker you get this memorized. So we started last week. We went back to it again on Friday, and we're coming back to it again today. We'll come back to it again tomorrow. Okay? This is changing of the forms between exponential and logarithmic forms is so important. Okay? So, with that being said, warm up with those two warm-up problems, please. So when we were solving on Friday, we said step one was we needed to isolate if it was a log or if it was an exponented term. Here in this first one, we have an exponented term. It is isolated, so we can switch forms with it. If I switch forms with it, it's in exponential form. I need to go into logarithmic form. So we would have log base 2 of 15 equals x minus 8. Log base 2 of 15, we would do log of 15 and then divide that by log of 2, common logs. Or we do natural log of 15 divided by natural log of 2. And we should get, or you should have gotten there, 3.906890596. Then we would add 8 to both sides, giving me 11.906890596. Then we would round to 3 decimal places. So we would say that our final answer here would be 11.907. Then we would go back and we would check it. So if we check with 11.907, that's fine. We're going to get something close to 15. If we check with it being our answer, we non-round it, we would get exactly 15. So 11.907 minus 8 is going to be 3.907. 2 raised to that power and I get 15.00113754 because the rounding is not exact. We're okay with it. It's close. It's within 1,000. Second one, log case, because I see the word log. Log term is isolated, so I can switch forms with it. My base is 3, my exponent is 2, and that is equal to my argument of x minus 6. 3 squared is 9. Add 6 to both sides. 15 is x. 15 minus 6 is 9. Log base 3 of 9. What exponent do I need to put on to 3 to get 9? That's 2. 2 is equal to 2. Checks out. Okay? So last week we talked about exponential problems and how to solve them. We talked about singular log problems and how to solve them. We talked about log equals log, and we talked about exponent equals exponent, how to solve all of those. There's one style of problem that we haven't gotten to yet, and that's when we have two or more logs and some extra stuff. In that case, when you've got two or more logs, and you can't get them into log equals log form, then what you have to do is you're going to have to use the three properties of logs or logarithmic functions. And here are those three properties. Okay? I'll give you a few moments to write them down. So the first one is called the product property. And the product property says that if you're adding two logs with the same base, that's key. They have to have the same base. If you're adding two logs with the same base, what you can actually do is you can actually just multiply those arguments together to combine the two logs. So there's the two arguments, and they multiply together, and then it condenses it down into one log. Now, back in Algebra 2, you guys probably spent some time expanding and condensing logs. And so you would take this ugly-looking log expression, and you would write it out as far out as you could expand it. Or you had this big, lengthy logarithmic expression with multiple logs in it, and you condensed it all the way down to one. So that's kind of that same type stuff. We are not going to expand and condense logs. We just don't have the time. And so we're just going to go into it. We're just going to get into the good stuff. We're not going to get into the boring stuff. Okay? Then on the quotient property says that if you're subtracting logs, then you would divide those two arguments. First one goes on top, second one goes on the bottom. And lastly is the power property. The power property of log says that if your argument has an exponent on it, you can take that exponent and you can put it out in front, and then you're just multiplying by that exponent in the end. Okay? Now, of these three properties, the main one that you are going to, well, first off, you're probably going to use the one that you're going to use the most is going to be the product property. The one that you're going to use the next most is going to be the quotient property. The one you use the least is the power property. Okay? So, how do we utilize these properties? Well, we're going to have a problem that looks like this. Log base 2 of x plus log base 2 of x plus 1 is equal to 1. And I'm going to say, solve it. And you're going to say, way too many logs. I'm out. Okay? And you say, no. Tap the brakes. First off, are our logs of the same base? Crucial that the logs are of the same base. Okay? Are we adding or are we subtracting the two logs? Actually, even before that, can I get it into the log equals log? Can I get it so that it's log equals log? But can I do that? Yeah, I could. But what's wrong with doing that? The 1 is still over on that other side. It's not so much the negative log, because we can put that negative 1 exponent in using the power property. But it's that other one. It's this one over here that's preventing me from doing that. Okay? Because I wouldn't have log equals log. I'd have log equals 1 minus 1. So then the next question is, Am I adding or am I subtracting these logs? Adding or subtracting? Adding. Okay? So that is product property, right? Adding of the logs is product property. So this would change over to be log base 2 of x times x plus 1 equals 1. The left side of my equation becomes that. Okay. Now, why is that important? Because now what next? Now we can switch forms. We've got our log isolated, so now we can switch our forms. So if we switch our forms, then it becomes 2 to the first power equals x times the quantity x plus 1. Okay. 2 to the first power is 2. X times x plus 1 is x squared plus x. How am I going to go about solving 2 equals x squared plus x? Now, could you? You should. Yes. Okay. So subtract 2 from both sides. That gives me 0 equals x squared plus x minus 2. Now what? Factor. Okay. If it's not factorable, then what? Quadratic formula. Okay? So factoring, we'll always try that first. Are there two numbers that multiply together to be negative 2 and add to be positive 1? 2 and positive 2 and negative 1. So this would become 0 equals x plus 2 and x minus 1. Okay? Then what? Set the two factors equal to 0. So that's going to be x plus 2 equals 0 and x minus 1 equals 0. So I'm going to get x equals negative 2 and x equals positive 1. Yes? Okay. Now what? Got to check it. Okay. So let's check the first one first. Log base 2 of negative 2 plus log base 2 of negative 2 plus 1. Log base 2 of negative 2. Why doesn't it work? Args got to be positive. Base and args have to be positive. Okay? So this one doesn't work, which means negative 2 is extraneous and doesn't work. Okay? Then we got to check x equals positive 1. We would have log base 2 of 1 plus log base 2 of 1 plus 1, which would be 2. Log base 2 of 1. What exponent do I put on 2 to get 1? 0. Okay? So this part here is 0. Log base 2 of 2. What exponent do I put on 2 to get 2? 1. 0 plus 1 is 1. And 1 is equal to 1. So our answer here then is x equals 1 and only x equals 1. Okay? You try that. So got to combine logs. Got to switch forms. Three squared is 9. Quantity x minus 9 times quantity x minus 3 is x squared minus 12x plus 27. Got to get it equal to 0. So we're going to subtract 9. So I get x squared minus 12x plus 18. Two numbers that multiply together to be 18. What are my options that multiply together to be 18? 1 and 18, 2 and 9, 3 and 6. Okay. Any of those add up to be negative 12? Nope. So that leaves us quadratic formula. So we would have here x is equal to negative of negative 12 plus minus the square root of negative 12 squared minus 4 times 1 times 18 all over 2 times 1. So that's going to be positive 12 plus or minus 144 minus 72, which is 72. (72) is the square root of 36 times the square root of 2. So I get here x is 6 plus or minus 3 square roots of 2. Okay? Now, if I break those up, I've got x equals 6 plus 3 square roots of 2. Approximately, how big is 6 plus 3 square roots of 2? (10.24-ish). Okay, so let's check 10.24-ish. Okay, so that would be log base 3 of 10.24 minus 9. 1.24 plus log base 3 of 10.24 minus 3, 7.24. Check out and see if that is close to 2. Do it now. Everybody's got a calculator. Everybody should be checking, because I hate to break it to you, you have to check these. Have to. in green. If you type it in right, you should get 1.997731692. What you can always do is you can always just break those up into two separate problems and then write those each down and add them together. Okay? That is within 3/1000ths of 2. I would say that that's close. Okay? So that one checks out. Okay? My other answer is x equals 6 minus 3 square roots of 2. And how big is 6 minus 3 square roots of 2? (1.75-ish). Okay, right? So let's check that one out. Okay? Go. 1.75. Should be done by now. Because on the first one, we get log base 3 of 1.75 minus 9, which is negative 7.25. Do I need to go any further? No, because I have to have a positive argument. So right then and there, this one is gone. Okay? So my only answer here would be x equals 6 plus 3 square roots of 2. Now, when you're checking them, on both of them that we did today, one of the answers was extraneous. Okay? And that's the majority of the time you're going to get that. Some of the time, you might get where both answers are extraneous. And then that's a no solutions case. Some of the time, you might get where both answers work. Okay? The reason or how you figure that out is you have to check all of your answers. You don't get an option. It is not an option for you to not check your work. Okay? Because the possibility exists of extraneous solutions. Okay? The pink worksheet that you got last week, you now have the ability to do all of those problems on there. And that worksheet is going to be due on Friday of this week. Wednesday, the next day that we have class, we will be working on word problems. Thursday, we will be reviewing. And Friday, we will be testing on Unit 5.